But in a nutshell, sourcing refers to connecting or interrupting the voltage source between the plus voltage source and the device that you're driving. Syncing, on the other hand, refers to breaking the circuit or opening and closing the circuit between the device and the power ground. Yeah, that really applies more to SnapIO.
In this direction here. Okay, so now how do we establish current flow? Well, we have to have a potential difference. Okay? So a diode with plus 5 volts on this side and plus 5 volts on that side, will it have any current going through it? The answer is no, because there is no potential difference. Okay, so that light emitting diode will not emit light because there is no current flow through it. Whereas this one would, because there is a potential difference across it. Current flows and light will emit from it. Okay, now what happens here? Plus 5 volts on this side, 0 volts on this side. There is a potential difference, but remember the definition of a diode. It's an electrical check valve. Current tries to go in this direction, but it can't. Okay, so that thing will not emit light. Okay, so now here is the kind of the purpose of this lecture here. What causes an LED to light in a digital circuit, a 1 or a 0? And the answer is it depends. And it depends on your arrangement of the LED. And that's either a sourcing arrangement or a syncing arrangement. So I'm going to draw your attention to these two diagrams, which I've drawn here. The first arrangement here. Think of signal A. Obviously, on the other side of that inverter is not A. It's the inversion of it. And A, signal A, could have any value, as indicated by this timing diagram. The inversion of it, not A, could look like that. Okay? There's A, there's not A. So if A, let's say, for example, was a 0, what does not A's value? It's a plus 5 volts, or a 1. So is there a potential difference at this point across that diode? Yes, there is. And current flows because it's an electrical check valve and it's flowing in the correct direction, so that LED will light. So what's happened there? A 0 has caused that LED to light. A 0 on A has caused that LED to light. Now what happens when A is a 1? When A is a 1, it's inverted to a 0. And what do we have for a potential difference? So if it's 0 volts on one side and 0 volts on the other, current does not flow and the light does not light up. So in this arrangement, our first arrangement, which we talked about here, it looks like a 0 is going to cause it to light up, the LED. But what this is called, so our next slang term, this is a sourcing arrangement, because A is providing the energy for the LED to light up. It's sourcing the energy. What I'm talking about is this NOT gate is sourcing the energy for the current to flow through the LED. Okay? And that makes sense because when that's a 0, it's creating the potential difference. The gate is creating the potential difference to drive current through the LED. And this is in total contrast to this arrangement over here. And this is what's known as a syncing arrangement. Okay? So now notice on this side of the LED, we have a plus 5 already. So what would cause that to light? a 0 on this side, basically establishing a potential difference across the LED and current will flow. So what do we need to get a 0? Well, A needs to be a 1. Okay, so the answer is, like I said earlier, it depends, a 1 or 0, depending upon your arrangement to get the LED to light. Okay, so a sourcing arrangement, excuse me, a sinking arrangement, this is the way it was described to me as a student. You've got a sink full of water, i.e. plus 5 volts. All it needs is a path to ground for current to flow. And all you do for path to ground, you pull out the plug and it flows to ground. Okay? So what you're doing is you're providing a sinking to ground. You provide a ground as a path for a sinking arrangement. Okay? So now in the opposite case here, what happens when A is a 0? It's a 1 there, i.e. a plus 5 volts for TTL logic. There is no potential difference, and our LED does not light. Okay? So sourcing versus sinking, very important concept in your labs, because what causes your LEDs to light up? In this sourcing arrangement, a 0 causes it to light up. In this sinking arrangement, a 1 causes it to light up. Okay, so if I gave you 4 LEDs, and let's say this guy's lit, this guy's lit, and you are in a sourcing arrangement, what does that represent? Well, if you're taking signal A there, basically this would be A0, 1, 1, 0, and what I'm doing is A3, A2, A1, A0. But if I was using a sinking arrangement, that would be 1, 0, 0, 1. Okay, get it? Because you're going to get very confused in labs if you are thinking that you're in a sinking arrangement, but you're actually in a sourcing arrangement, because as you can see, they're totally opposite of each other. Just think of what causes that LED to light up. Okay, sourcing versus sinking, two important concepts to distinguish when you're working with digital circuits.